So today we've learned that a log is another way to write exponents. You've learned how to convert back and forth between log form and exponential form, and you've learned how to evaluate logs by turning them into exponential equations. So what if an exponential equation can't be solved? And what do I mean by that? Well, let's look at this first example, log base 2 of 54. What you just did was you would say, okay, I'm going to set this equal to x. So we would write it as an exponential equation, 2 to the x equals 54. And then we try and figure out 2 to the what power is going to give me 54 so that I would be able to know what x is. Well, 2 to the 5th is 32 and 2 to the 6th is 64. So I'm not going to have a whole number that's going to get me 54. So that number is going to be somewhere between 5 and 6. So how do I figure out exactly where between 5 and 6 that is? Well, that's where our log change of base formula comes in. So how do we use that? Well, log base b of a, we rewrite this as the log of a over the log of b. And what does that mean? It means we've turned our logs into base 10. Okay, so log base 10 of a over log base 10 of b. How do I remember that a goes on top and b goes on the bottom? Well, a comes before b. Or base, the b, on the bottom because it's the base. Let's use this formula now to actually figure out what our x is going to be here. So the log of 54 over the log of 2. Well, we know from here, we figured out it's got to be somewhere between 5 and 6. But how does this help me? Because I don't know the log of 54. I don't think you know the log of 54. But you know how we can find logs? This is a calculator thing. So I know you might not have scientific calculators at home. So lucky for us, Desmos has a scientific calculator. So you're going to go to desmos.com. And then usually it brings up that screen where you can just start graphing. And underneath, there's 3 little pieces. They look like this computer looking thing here. You're going to click on the one that says scientific because we're going to be dealing with calculators. So you're going to click on the one that says scientific, and that's how we're going to use the calculator to evaluate our logs. So now we have this Desmos calculator. And what we're going to do is I'm just going to go over, I don't see log on this screen. I don't know why. Yeah, let's hide them. Okay. So I don't see log on this screen, but if I go over to the function part, here's my log. So I'm going to say the log of, well, now I need numbers. So I'm going to go back to main 54, 50. I don't know why. Okay. 54. There we go. Close my parentheses, divided by the log, go back to the function, of 2. And that seems like a lot of work. We got to go back and forth a lot. I'm going to tell you can use your keyboard for this. I hit enter, and so here I have 5.755, and we're just going to round to 3 decimal places here. So like we said before, we knew it needed to be between 5 and 6. And so now we found how exactly where between 5 and 6. So let's look at this one. Log base 5 of 9. Well, I cannot write 9 with 5 as a base. So let's use our base change, the log of 9 over the log of 5. And let's plug those into the calculator. And like I said, I'm just going to stay on my function screen and I'm going to use my keyboard. So the log of 5, the log of 9, just kidding, divided by, that's the slash, the log of 5. Close your parentheses, hit enter, and here I have 1.365. Let's look at this one. So I have a fraction. That doesn't mean anything. It's totally fine. The log of 1 over 36 divided by the log of 7, well, we do it the exact same way. So the log of 1 divided by 36, and we just need to make sure that we close the parentheses, the whole parenthesis over the 1 over 36, divided by the log of 7. close my parenthesis, hit enter, and that gives me negative 1.842. And that makes sense because how do I get a fraction with a negative exponent? So it makes sense that I have a negative here. Let's look at this one, log base 10 of 249. And so there's a couple ways to do this. If you don't see the easy way right off the bat, no problem. We're just going to use the base change. So log of 249 over the log of 10. And let's plug that in. The log of 249 divided by the log of 10. And what do I get? I get 2.396. And so what's this easy way that I speak of? Well, remember, when I have a base of 10, I can just rewrite that as log of the number. So if I come over to my calculator again, I have log of 249. I should get the same answer we've already got. And do I? Yes, 2.396. I want to go over one more type of problem here. And this time I don't have a log. I have 7 to the x equals 31. Well, I know that I cannot write 31 with a base of 7. It's 31 is not in that 7 column on your exponent base change sheet. So how do I get to write it using the log base change formula? What do I need to do? Well, first I need to rewrite this as a log. So I know my log base b of a equals x. Well, that's how we write it. So let's fill that in here. The log of, or log base 7 of 31 equals x. And now I can use my base change. So log of 31 over the log of 7, and I'm going to come over to my calculator, log of 31 divided by the log of 7, hit enter, and I get 1.765. Okay, and that's how we're going to use logs in order to solve exponential equations that can't be solved just by using your base change sheet. You're going to practice some now.